Welcome. All right, so now let's continue on with this problem. We have a product rule, all right, and we have a chain rule, all right. So u here, and waiting for my u, is equal to, oh, I didn't get my u. There we go. U is equal to, and we can think of this, that cosine cubed x, as just cosine x all cubed, right? And then the v is sine x all squared. All right, so we got a chain rule here. All right, so we have blop cubed, that's going to be 3 blop squared. I'll fill in the blop this time. All right, so 3 blop squared. All right, and then we need the derivative of the blop. All right, so we're going to take the derivative here. So d dx there, that means take the derivative. We'll take the derivative of the inside part, which is cosine x, right? And that's equal to negative sine x. So let me move v down a little bit. All right, so the final du is going to be, let's move the negative in front. Right, so we have this part and that part. All right, so we have negative 3, and I'm going to put the, it doesn't matter who goes first. I'll put the cosine, I guess, first. But let's rewrite that with the square where it really belongs, where it's conventionally written. So negative 3, and we have cosine squared x, and then we have a sine x, right? So that negative there, that's just a coefficient, right? So that's just the same as a negative 1, right? So that's a negative 1 times a positive 3. Let's do the same thing with the sine x squared, or sine squared x. All right, so we have our derivative is going to be 2 blop, 2 sine x. And then let's take the derivative of the blop. Take the derivative of the sine x, right? And that's just cosine x. All right, so dv here, the final dv, because it's this times that, we have the 1 coefficient, and that's the 2. So we have 2 sine x cosine x. All right, so now let's put that all together with the product rule. So f prime of x is the first, which is cosine cubed x, times the derivative of the second, which is the 2, I'm going to put parentheses here, the 2 sine x cosine x, plus the second, which is sine squared x, and we're going to multiply that times the derivative of the first, which is the negative 3 cosine squared x sine x. And now we need to combine all the like things, and we need to make sure we have if we have any coefficients that they go first. All right, so we're going to clean this up. F prime of x is, all right, so that 2 needs to go first. All right, so the 2 there. And then we have a cosine cubed x and a cosine x. Well, if you multiply something cubed, say something to the first power, that's going to be something to the fourth power. So that's going to be 2 cosine 4x, and then we have one little o sine x, and then plus, because I took up too much space on the side there, we've got a coefficient of 3, and since it's a negative, we may as well just replace that plus there with the minus. Minus 3 times, and let's see, we've got a sine squared x and a sine x. That's going to give us a sine cubed x, and then we have a cosine squared x. And there we go. That is our derivative right there. All right? Hopefully you didn't find that too bad. All right, so just be careful with your work, and I know you can get it. We're going to do, I think I had 5 problems or 6 problems, and that's 1. Here we have a chain rule. The outside part is the 3 sine blop. That 3 does not count as a product. That's just a constant multiple. All right, so 3 sine blop. Right, and so the derivative of the outside, the 3 sine blop, is going to be 3 cosine blop. The inside part, g of x, was the pi x plus 4, and the derivative of that is just pi. Right? Pi is the coefficient. X, the exponent will reduce by 1. That will be down to the 0 power, so x won't be there. And the derivative of the 4 is just 0. All right, so now we want to write our final derivative here. So we're going to have dy dx equals the outside, which is 3 cosine blop. And what's the blop? It's pi x plus 4 times the derivative of the blop, which is pi. All right, we need to combine those two coefficients. We shouldn't have one of them over there. So all we got to do to simplify this is make it 3 pi cosine pi x plus 4, and we've got it. And we're done. All right, that one wasn't too hard. That was actually a pretty easy one, because that inside derivative was pretty easy, and it was only one chain. This one is the worst problem I have up here in this particular lesson, and I almost contemplated not going over it. But I will try to keep it on one page so that we can take a look at a quotient. All right, and so it's a chain with a quotient inside, which has got to be one of the longest problems. All right, so the we're going to use the quotient rule here, and so a little reminder of the quotient rule. It's going to be the denominator, because you use numerator and v is denominator. So it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. All right, so let's take those derivatives, because, well, that's the easy part. All right, so here we have, well, we have a product rule. So this is a product inside a quotient inside a chain. And I don't usually deal with the inside stuff first, but since the outside is simple and the inside is not, I decided to deal with the inside. All right, so here we have a product rule, just to make things interesting. However, after you see this problem, everything else will seem easy. All right, so that's going to be the first, right, just a little reminder here, it's u times dv plus v times du. All right, so, and actually I shouldn't use u's and v's again, but since I've already used u's and v's everywhere else, so let's just call it, because we're talking about this one, all right, okay, we won't even write down the product rule. If I use u's and v's again, it'll confuse you with the quotient rule. All right, so the derivative here, let's just do the derivative. And I'll just say what it is. It's the first, all right, so it's going to be x times the derivative of the second, that's cosine x, plus the second, which is sine x, times the derivative of the first, which is just 1. So the derivative here really isn't too bad for a product rule. All right, so du here is x cosine x plus sine x, because I don't need that 1. The derivative of the dv here is really simple because it's just 2x. All right, so that's the nice part. All right. Let's do the outside part real quick, and then we'll come back to the inside, because the outside just couldn't be any easier. It's 5 blop. All right, so 5 blop. Here's our outside derivative. I'm going to write it small because I know I need a lot of space for that inside. Is just 5 blop to the 4th power, right? And the blop is the x sine x divided by x squared plus 1. There's the outside part. That was the simple part. Now the inside part. All right. So here is our inside part. And this is just going to carry down because we're going to need more than one step to do the inside part. All right, so here's the inside. All right, quotient rule. So the denominator, which is x squared plus 1, times the derivative of the numerator, right, which is x cosine x plus sine x. And already I'm running out of space. And I hate to have two lines on this one. We haven't even gotten to the minus part. That's just maybe, oh, come on. Don't be, I move it and it decides to be obstinate. There we go. Let's just squeeze everybody over as much as possible. There we go. Let's see if we can squeeze it in. Minus the numerator times the derivative of the denominator. I'm going to just put the denominator first, okay? Because that's what we would have wanted. 2x times is the derivative of the denominator. So that's the dv, the v prime. And so the u is just x sine x. And we can simplify that. All over, there, I squeezed it in, the denominator squared. X squared plus 1 all squared. All right. Actually, because I'm writing smaller, doesn't look that bad. All right, so, and what the heck, we'll keep rewriting that part there. All right, so we have 5 times x sine x divided by x squared plus 1, all to the 4th. And now let's see where we can clean up a little bit. All right, so we have x squared plus 1. We could, let's multiply that. We've got an x right here. Right, we could distribute the x. Can't do much with it with the cosine x and the sine x anyway. So now we can make that x cubed plus x cosine x plus sine x. And then we have minus, may as well multiply the 2x and the x together, 2x squared sine x. Now, I don't have any parentheses there, I suppose. We'll get rid of that last set. But we'll keep them for, oh no, we do need it at the end. There, we need these parentheses. All divided by x squared plus 1 squared. Well, actually, this hasn't been as bad as, because I wrote nice and small, and it all fits on one line. All right, can we do much of anything to simplify? Well, I could pull out an x out of both those terms, because everything's got a factor of x in front of it, but it's hardly worth the effort. Can't cancel out the x squared plus 1s at all because only one side has it, not the other. We could, and we can't even combine the two x squared plus 1s in the denominators there because 1's to the 4th power. So I say this is done. And actually, this wasn't so bad. Last year, I wrote too big, and then I had 2 lines, and then you try and keep track because it goes down a line. Didn't I put a box around that? So I was going to move it over a little bit. It's fine where it is, and I'll rebox it. So there, we're done. We're done with that one. All right, there's really just nothing much else we can do to make that much nicer. All right, so it looks pretty ugly, but actually in the end it wasn't too bad because we couldn't simplify very much. As long as we keep track of everything. All right, so example of repeated use of the chain rule. Sometimes a chain rule needs to be used more than once to find a derivative. All right, so here's another example of a chain rule that is more than once. This one is, we've got 3, right? 3 parts here. All right, so let's rewrite this. Y is equal to, and we have sine x squared, and that's all to the 1/3 power. All right, so 1/3 power. So we have the derivative of the outside. All right, so the first part we have, let's just label it u, is going to be blop to the 1/3. And then the v part is the the derivative of sine blop, and then the w is the derivative of x squared. So the derivative of blop to the 1/3, there's 1/3 blop to the negative 2/3. And we'll simplify that up. We're figuring out the derivative because, well, I didn't provide myself enough space. The derivative of sine blop is cosine blop, and the derivative of x squared is 2x. All right, so let's take the derivative here. All right, so dy dx equals the derivative of the outside, and we may as well move that to the denominator. So it's going to be 1 divided by 3 times, and inside the blop is the sine x squared. All right, so that square, by the way, is on the x, not on sine. All right, and so that's the, and as soon as I put the parentheses, the exponent in there, we're done with that part. All right, so that's the first part. All right, the second part is the dv. All right, is we need the cosine blop. All right, and what goes in the blop but x squared. All right, so that's going to be times, I'll put a little times there, times cosine x squared. And then finally, our last little part here, times the 2x. All right, and now really the only thing we can do is just write that nicer. So dy dx, since we already simplified the negative exponent, the 2x is going to go in front. 2x cosine x squared, all divided by 3 sine x squared, I'll put that in parentheses, all to the 2/3 power. And there we go. So repeated use, but if we keep track of all the pieces, that's not so bad. And we're on to the next one. I think I've got maybe 1 or 2. I've got 2, but we're going to, so I did this, and this is in the next video. I did this, well, we'll do the first one. The first one's a little harder. We're going to do the second one as simple as possible, all right? I was going to do the long, drawn-out version, and I was like, let's just do it as simple as possible. So this one is a chain within a chain within a chain within a chain, right? And I rewrote it down below. So the outermost part is the 2, and then we've got secant, we've got 2 blop squared, right? So the outermost part, when I rewrite it, you don't notice it as much at first, and actually it kind of looks like a product rule, right? You might think, oh, I've got secant squared times sine x squared plus 1. And what's the clue that it's not secant squared times sine x squared plus 1 is that secant can't stand alone. You got to take the secant of something. And this is what you're taking the secant of, that whole thing there, all right? So if you rewrite it, it's a lot easier to figure out, right? So we have y equals 2 secant of sine of x squared plus 1, all squared. So just think of it as 2 blop squared. All right, so that's the outermost part. So the derivative of the 2 blop squared is going to be 4 blop. All right, so what's 4 blop? All right, and this time I decided to just label them all instead with u's and v's and w's as f of x, g of x, h of x, and I of x because none of those were used. All right, so 4 blop is just going to be therefore 4 times all that stuff. Secant of sine of x squared plus 1, and now let's say I got that parentheses closed, that parentheses closed, that parentheses closed. There we go. All right, so that's that first part. Now we need to take the derivative of, got to move in a little bit. So now we've got secant blop. So that's this part here. All right, so that's supposed to be purple. And no part of that looks purple. Trying to color code it here, Mr. Smartboard. It's late, I'm trying to finish. Trying to color code it. Color code it. Okay, so now we're taking the derivative of it. And that still doesn't look purple. So we're just going to go with red. Doesn't want to write in purple. I don't know why. It says purple up there. Anyhow, the derivative of the secant blop, derivative of secant is secant tangent. So g prime of x is equal to secant blop, tangent blop. And what's the blop? The blop is the sine x squared plus 1. So g prime of x is secant sine x squared plus 1 tangent sine x squared plus 1. Yeah, we can squeeze that in. And I actually do need the parentheses right there, because we're taking the sine of all those things. Oh, great. There goes my light. You can't tell, but I'm now standing in the dark. It's a good thing the board is lit up. All right, so now let's look at the next part. Now we got to go in a little bit more. And so now we're taking the derivative of this part. All right, so we have sine blop. What's the derivative of sine blop? Cosine blop. What's the blop? It's cosine x squared plus 1. This parentheses is not in the right spot. There we go. All right, and so now we're at the innermost spot, the x squared plus 1. What's the derivative of x squared plus 1? Now we don't even need any blops. That's just going to be 2x. So our derivative will include all of these parts. Let's see if I get purple now. It's going to include, now I get purple. It's about time. It's going to include that part and that part and that part and last but not least that part. All right, so x is, all right, so now I've got to use more than one line. 4 times secant sine x squared plus 1. Take that and multiply it by, can I even fit that in there? I'll come down here. Secant sine x squared plus 1 tangent x squared plus 1. And I closed that parentheses, got that parentheses, now got that parentheses, times cosine x squared plus 1, all times 2x. So we've got lots of things that are multiplying there. So doing it off to the side and boxing those in makes it easier. And now another thing you can do is underline what has to be multiplied. We got to multiply the 2x and the 4. Those are coefficients. All right, so dy dx is, let's just make that 8x. Maybe we can get this on one line. Do we have any other things that could be multiplied? Well, I've got no exponent on this thing anymore. I have a secant sine x squared plus 1 times another secant sine x squared plus 1. We can just make that secant squared sine x squared plus 1. Back with having the square. So obviously the derivative is more complicated than the original function. All right, anything else? No, we're out of things to multiply because we got a tangent and a cosine. So all these things are just multiplied. So we can feel free to multiply anybody that matches. All right, so, oh, oops. Well, let's fix the tangent. It's not tangent x squared plus 1, it's tangent of sine x squared plus 1. Somehow the sine got left off. How about on the cosine? No, cosine I was fine, because that's the derivative of sine blop. No more sine there. So this one, sorry, it was right over there, but I forgot to write in the sine of x squared plus 1. Just left the word sine off there. And I think that's the right amount of parentheses. All right, so this should be times tangent sine of x squared plus 1, and almost fit it in, times cosine x squared plus 1. And there is our final derivative. And that's, I promise, as many chain within a chain within a chain, that's as many chains as we're going to get to, 4. All right? And so there that is. And you can multiply so long as it's the secant of the same thing. And there were 2 of them that were just secant of sine x squared plus 1. And this is the last one. And at the 25-minute mark, and this is the second video, would you like to do this as simply as possible? I had the more complicated. It took me like 20 minutes. I'm going to give it, and I cut it out, because I'm going to give you the simplest thing. The simplest thing. All right, so what is that when we're taking the limit of a difference quotient? Right? So remember what that is? The limit of a difference quotient equals the derivative. And there are times when I'm going to want you to use the difference quotient and show that it's the derivative. But I decided that this isn't going to be one of them. All right? This one, we did something very similar without that 3 there. That 3 just kind of adds one more dimension to it. And I decided, you know what? On this one, if you can recognize, and there'll be a problem like this maybe on an upcoming quiz or test, and it's multiple choice, and you can recognize that this is the limit of a difference quotient, it's the derivative, right? So what are we taking the derivative of? We're taking the derivative of cosine 3x, right? That's what we're taking the derivative of. And we're using average rate of change as the difference between those 2 points goes to 0, right? And so to do that, we take the limit of that difference quotient. But what it is, it's the derivative of, we're taking the derivative of cosine 3x. That's what we're doing when we're doing a limit of a difference quotient here. All right, so limit of a difference quotient equals the derivative. Now, if I wanted, I'll just explain it in simple terms like this. We're not going to go out and put a whole long explanation to it. We'll just leave it as that one little thing there. The limit of a difference quotient is the derivative. So we're going to take the derivative of our function. And actually, let's call it f of x instead of y. F of x equals cosine 3x. And I think it's appropriate to do it that way because we've been working on the chain rule. And this is a good one. Nice, easy way to end this podcast. So if f of x is cosine 3x, f prime of x is going to be equal to the outside derivative times the inside. Right? So the outside is cosine. So the derivative of cosine blop, actually I'll even write it like that. All right, so the outside is cosine blop. The derivative is negative sine blop. And in this case, the blop is 3x. And the derivative of 3x, why, that's just 3. So our final derivative going to be the derivative of the outside, right? Which is, and then actually, let's take the derivative of using the chain rule. Add that to your notes real quick. Now, final derivative. All right, so it's going to be negative, and let's multiply the negative and the coefficient there to make that negative 3, and then we're going to have sine 3x. Right, because we're going to multiply the outside derivative and the inside derivative, right? There's for the outside, there's for the inside. And there you go. Nice, simple way to end this podcast rather than doing this the long, complicated way and actually solving that out. Because we'd have to bring in a whole bunch of other rules because we've got a cosine of a sum. All right, so if it's a multiple choice question and I'm not asking you to use the limit of the difference quotient to find the derivative, and you recognize that that's the derivative, you may use other ways to find the derivative. All right, little hint there for questions on an upcoming test. All right, bye for now.